Okay, so in this example here, we definitely have more of a challenging problem, but once we go through it, hopefully it will make more sense. And I'm actually going to show you two different methods how to do this problem. The first method is going to force you to substitute in a way that is not very obvious, but it's good that you get exposure to this because as you move to the higher math classes such as pre-calculus and calculus, you are going to have to substitute in ways that are not very obvious. So this example here will be good practice. Then once we're done with method 1, I'll show you method 2, which is way easier and you can get the answer in less than a minute, okay? But I want to show you method 1, that way you have exposure to substituting in ways that are not very obvious, okay? So let's go ahead and read the problem. It says a circle is inscribed inside a square. Find the percent of the area that is shaded in red and leave your answer in terms of pi. So again, they want to know what percentage here is going to be shaded in red. And we have a circle inscribed in a square and it's all proportionate, right? So what you need to think about, I could enlarge this picture or shrink this picture and that percentage is always going to remain the same, all right? Because again, it's being inscribed inside that square. So it doesn't matter how big this is or how small, it's always going to remain the same because it's proportionate, all right? Now, the first thing we want to do is start labeling our parts. So they don't give us anything here, but we're going to start labeling things. And I know that, well, going from the edge of this square, okay, to the center of this circle is going to be my radius, okay? So I'm going to put R here. And now let's think about how we can get other parts of this image in terms of R. Well, what about the side of a square? I know that this right here, okay, going from here to here is going to be one side, which is really going to be what? If we want to keep things in terms of radius, I could say 2R here. Because remember, that's going to be twice the radius. If I go from one end to the other end of the square, right, that's twice the radius. So now I have two parts in terms of my radius, and you'll see why we want to do that, okay? So think about this. How are we going to get the percentage of that red region if we aren't given any values? Well, think about what we need to do here. First, we have to figure out what the area of the square is going to be. So area of square. Then we're going to have to figure out what the area of the circle is going to be. So we're going to put area of circle, okay? And if I subtract these two, that's going to give me the red region. So if I do area of square minus area of circle, that gives me that region in red. But remember, they want the percentage. So think about this. When we do a percentage, we do it out of the total. What is the total of this image? Well, that's going to be the area of the square. So this whole thing divided by the area of the square, that's going to give me the percentage of that red region, okay? So let's go to the next page so we have room to do this problem and you're going to see how it works out. So here we go. Let's go ahead and go right into the problem. And I'm going to write this above so we don't forget. And that is going to be area of square minus area of circle all over area of square is going to give us that percentage in red, right? So I'm going to say percent of red region, okay? That's how we're going to get our answer. So let's start figuring it out. Area of square, what is that going to be? So area of square, if we're just dealing with a square, we know that's going to be side squared. But based on what I have here, my side is actually 2R. So I'm going to rewrite it as 2R squared, which ends up being 4R squared. So that is going to be the area of the square. Now, what about the area of the circle? Well, area of circle is going to be pi radius squared. Okay, pi radius squared. And so nothing's going to change there for me because my radius is R. All right. So now we're going to go ahead and set it up. So area of square, that's going to be 4R squared. Minus area of circle, that's going to be pi radius squared, okay, all over the area of the square, which is also 4 radius squared, right? So what do we do from here? Well, think about it. I have two terms on my numerator, right? Here's one term, here's another term, all sharing the same denominator. I can break this apart, okay? So that's what I'm going to do here. So getting rid of this here, I'm going to go ahead and break it apart. So I'm going to say 4 radius squared all over 4 radius squared. And then I'm going to put minus pi radius squared all over 4 radius squared. Now look what happens here. This one works out real nice. Radius squared, that cancels out. 4 divided by 4, that's 1, okay? And then when I look at this term here, radius squared will cancel out. I'm left with pi over 4. So my final answer is going to be 1 minus pi over 4, okay? And there we go. So this right here is going to be the decimal version of the percent that is shaded in red. Now, if you wanted the actual percentage, you would plug this into your calculator and you would multiply it by 100. Why don't we go ahead and do that right now? So if I do 1 minus pi over 4 in my calculator, I end up with 0.2146, okay? And so again, that is the decimal equivalent of the percentage. And so if we want to write it as a percentage, we multiply it by 100 or move that decimal point over 2 places to the right, and we get 21.46%. So that is the percentage of the region that is shaded in red, 21.46%. And again, leaving it in terms of pi, we could say 1 minus pi over 4, okay? So that is a more challenging way of doing the problem. You have to think differently about doing it that way. So that would be method 1. Now let's talk about method 2, which is definitely an easier route. So let's go ahead and clear this and do method 2. Okay, so here is method 2. And again, this method is definitely going to be a lot easier. So think about at the beginning of the problem how we were talking how this image here of the circle inscribed in the square is all proportionate. So I can use that to my advantage because I know that if I enlarge it or if I shrink it, everything will remain in proportion. So I can simply just call my radius whatever I want here. It won't matter. I could just say that the radius is going to be equal to 1, okay? And if I know that the radius is going to be equal to 1, that means the side length of my square is going to be 2 because 2 times r, or in our case here, 2 times 1 will give us 2. So the side length of my square is going to be 2. And so remember what we're trying to find here. We're trying to find the area of the shaded region. So again, you're going to do area of square minus area of circle all over area of square. So using the numbers that were provided here, how do I get the area of the square? Well, that's going to be side squared. So if my side is 2 and I square that, I get 4. So the area of the square is going to be 4. Then if we look at the area of the circle, what's that going to be? So area of circle, well, that's pi radius squared, but we know that the radius is 1. So if I do 1 squared times pi, I'm left with pi. So the area of the circle is going to be pi. So now we can put it all together using our template right here. So we're going to do 4 minus pi, right? That's area of square minus area of circle, divided by area of square, which is 4. And so we're going to do the same thing here. We're going to break it apart. We're going to do 4 over 4 minus pi over 4. And when we do that, 4 divided by 4 is 1. So we get 1 minus pi over 4. We get the same exact thing, right? And so that is definitely an easier way to do the problem. But again, method 1 is good practice for what is to come in the higher math classes, right? As you get into pre-calculus and calculus, you're going to have to substitute in ways that is not very obvious. So that is good practice and a good little intro and gives you good exposure to what you're going to be seeing in the future. So I hope that the video helped you. If it did, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe so you get more math videos in the future, and I'll see you in the next one.